Once upon a time in galactic history, a cluster of stars detonated to form fantastical supernovas. The blasts were so strong, their sparkly leftovers pushed the surrounding shroud of interstellar gas outward until it drifted into a cosmic bubble, 1,000 light years wide. A giant blob that's still growing now. By sheer coincidence, experts say, our very own sun flew directly into this bubble. Now we live smack in the middle of it, earning the globule a fitting name, the local bubble. But what exactly is a local bubble? Let's find out. Welcome to Space World. In today's video, we are going to talk about a mysterious local bubble that is surrounding our very own solar system. So if you want to know more about it, then stay with us until the end of the video. Our solar system is situated almost exactly in the middle of a giant, relatively empty bubble in space. This mysterious bubble is 1,000 light years across. Inside the bubble, temperature of the interstellar medium is greater than that outside the bubble. For years, presence of this bubble has baffled scientists. A strong explanation behind existence of this bubble, known as local bubble, was not present. But now we may know why this bubble exists. Catherine Zucker, an astronomer at the Space Telescope Science Institute in Baltimore, in the U.S., who led the new study, said astronomers had known about the local bubble since the 1970s. They suspected supernovae pumped up the bubble over the course of millions of years, but were less certain about when or where the whole process kicked off. That's something that this study provides, Dr. Zucker said. We can actually turn the clock back, see the supernovae go off, and you can see this bubble grow over time. So let's begin with what exactly is a local bubble. The local bubble is a cavity containing sparse hot gas around 1,000 light years across on one of the Milky Way's long, looping spiral arms. Inside the bubble, it's too hot and the gas too scant to generate new stars. But its shell of cold, compressed hydrogen gas, pushed outwards by the force of multiple supernovae, is prime stellar nursery material. 7 clusters of baby stars around 10 million years old or younger are dotted around the bubble's surface. Think of the whole process like Swiss cheese, Dr. Zucker said. Basically, you have all these supernova explosions blowing out bubbles in the cheese, and then the stars are forming on the cheese around the holes made by the dying stars. However, despite its name, the local bubble is not spherical. It's shaped more like a lumpy hourglass or peanut. And while our solar system is in the local bubble now, that's not always been the case. Around 5 million years ago, the sun's path took it and Earth into the local bubble. And there seems to be chemical clues of this entry left on the planet. When stars explode, they also dump a whole load of other elements produced when hydrogen atoms start fusing at their core. These elements are mixed with the surrounding gas and swept outwards with it. This means the local bubble shell isn't pure hydrogen. It contains these dregs of dying stars too, including a particular type of iron that's produced only by supernovae. In addition, previous studies found minute scraps of that type of iron that were deposited in Earth's crust a few million years ago, Dr. Zucker said, perhaps raining down on the planet as our solar system whisked through the bubble's boundary. But how did this bubble form around us in the first place? Well, tracing the history of the local bubble needed a powerful eye in the sky, such as the Gaia Space Telescope. Gaia mapped and traced the movement of young stars and, by proxy, the cold gas shell on which they sat. Dr. Zucker and her crew took that data and worked backwards, tracing the stars' trajectories back millions of years. The most likely scenario, according to their modeling, was the star that instigated the bubble exploded about 14 million years ago. It came from 2 neighboring clusters of stars and would have been one of the most massive stars in its population, said Themia Nanayakara, an astronomer at Swinburne University, who was not involved in the study. If a star is big, it goes bang first and creates a massive ejection and pushes it out, he said. But one big supernova is not enough. you need to have a few of them to create the local bubble. Therefore, Dr. Zucker's team calculated another 14 supernovae, give or take, went off over the next 10 million years or so after the first. Each added another hefty puff to the ever-expanding bubble and produced the warped blob we see from the inside today. Later on, in a paper published in the journal Nature, scientists offer novel details of the bubble saga using a 3D map of the enormous structure. Most surprisingly, they found it's the main reason we have an oddly rich neighborhood of young stars. This is really an origin story. For the first time, we can explain how all nearby star formation began, Dr. Zucker said in a statement. Talking about star formation, astronomers typically study 7 spots in space where stars seem to form most often. Zucker's study saw each one sitting right on the surface of the local bubble. The team believes that starry bubbles similar to the one encompassing us show up all over the universe, but also that our positioning directly at the center of one is extremely rare. As we mentioned before, the concept is comparable with space's fabric, resembling a holy Swiss cheese, with each hole representing a star formation center. Somehow, we're in one of the cheesy holes. Because our home star set up shop inside the local bubble, every time we peer out at the sky, we're witness to tons of starbirths. Moreover, beyond that stellar serendipity, the team's awesome 3D animation of the local bubble, which you can play around with here, sheds light on the structure's evolution. For instance, the researchers calculated that about 15 supernovas are responsible for the blob's genesis, which occurred approximately 14 million years ago. The Sun appeared to have entered the orb about 5 million years ago, and the bubble seems to be coasting along at about 4 miles (6.5 kilometers) per second. Apart from Zucker, Alyssa Goodman, an astronomer at Harvard and Smithsonian's Center for Astrophysics and author of the study, called the team's findings an incredible detective story, driven by both data and theory. In the future, the researchers hope to continue unlocking the secrets of interstellar bubbles, like the local bubble, by applying their software to 3D maps, those that lie deeper in the universe. We can piece together the history of star formation around us using a wide variety of independent clues, supernova models, stellar motions, and exquisite new 3D maps of the material surrounding the local bubble, Goodman said. However, Zucker wonders, where do these bubbles touch? How do they interact with each other? How do superbubbles drive the birth of stars like our Sun and the Milky Way? These questions are very much valid, and they have got scientists scratching their heads too. Adding to this, the local bubble is not dormant. It continues to slowly grow at about 4 miles per second. However, as we mentioned before, it has lost most of its oomph and has pretty much plateaued in terms of speed, Zucker said. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. And don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.